Hi guys, welcome to my YouTube channel. My name is Dhanushar. I'm studying in Sri Venkateswara College of Engineering. Our section is Ferrari. Subject is Introduction to Mechanical Engineering. Today is our topic is about four-stroke petrol and diesel engine. Four-stroke petrol engine. The working principle of four-stroke petrol engine is based on the theoretical Otto cycle, constant volume cycle. Hence, it is also known as Otto cycle engine. In four-stroke engines, piston performs four different strokes to complete all the operations of the working cycle. The four different strokes performed are suction stroke, compression stroke, power stroke, or expansion stroke, or it can be called as working stroke. And fourth one is exhaust stroke. The four different strokes, first one is section stroke, second one is compression stroke, third one is power stroke, and the fourth one is exhaust stroke. In that we can see the graph here, it represents pressure and the down is volume. In that, AB is section of air and petrol, BC is compared to compression of mixture, CD constitute constant volume combustion, DE represents the expansion stroke, EB exhaust valve opens, and BA exhaust of combustion product. First one is section stroke. The section stroke starts when the piston is at TDC and about to move downwards. During this cycle, inlet valve remains open and exhaust valve remains closed. Due to low pressure created by the downward moving piston, the charge is drawn into the cylinder. At the end of the stroke, the inlet valve closes. The section stroke is represented by the line AB and PV diagram as shown in figure. Second one is compression stroke. During this stroke, the compression of fresh drawn charge takes place by the return stroke BDC to TDC of piston. During this stroke, both inlet and exhaust valves are closed. The pressure and temperature of the charge increase, and this is shown by the curve BC on the PV diagram. When the piston reaches the TDC just before the completion of compression stroke, the spark plug ignites the charge and the combustion of the fuel takes place at the constant volume and is shown by the line CD on the PV diagram. The compression ratio in petrol engine ranges from 7:1 to 11:1. Third one is power stroke or expansion stroke or working stroke. At the beginning of stroke, piston is in TDC, and during the stroke, piston moves from TDC to BDC. During the stroke, both inlet and exhaust valves remains closed. The combustion of fuel liberates gases, and these gases starts expanding due to expansion, and the art gases expert a large force on the piston, and as a result the piston is pushed from TDC to BDC. The power impulse is transmitted down through the piston to the crankshaft through the connecting rod. This causes crankshaft to rotate at high speeds. Thus, the working is obtained in this stroke. Hence, this stroke is also called working stroke. Also, gas expands and does work on the piston, so this stroke is also called as the expansion stroke. Expansion stroke of gases is adiabatic in nature, and this is shown by the curve DE on PV diagram. As the piston reaches the BDC, the exhaust valve opens. A part of the burnt gas escapes through the exhaust valve out of the cylinder due to their own expansion. Fourth one is exhaust valve. At the beginning of the stroke, piston is in the BDC as shown in the figure, and during the stroke, the piston moves from BDC to TDC. During this stroke, inlet valve is closed and exhaust valve is opened. As the piston moves upward, it forces the remaining burnt gas out of the cylinder to the atmosphere through the exhaust valve. This is shown by the line EB and BA on PV diagram. When the piston reaches to the TDC, the exhaust valve closes and the it completes the cycle. In the next cycle, the piston which is at TDC moves to BDC, thereby allowing fresh charge to enter the cylinder and the process continues. Here we can see the four-stroke petrol engine 3D working. Four-stroke diesel engine. The working principle of a four-stroke diesel engine is based on the theoretical diesel cycle, hence it is called as diesel cycle engine. Suction stroke, compression stroke, power stroke, and exhaust stroke. The same as the petrol engine. Here, power stroke is also known as expansion stroke and working stroke. Here we can see the pressure and the volume. AB is represents the section of fresh air and BC represents the compression of air and CD represents the constant pressure combustion at D fuel supplies cutoff. D expansion stroke and EB is exhaust valve opens. BA exhaust of combustion product. Here is the graph we can see it and here this is called as a reversible adiabatic process. Section stroke. At the beginning of stroke, piston is in TDC and during the stroke, piston moves from TDC to BDC. During this stroke, the inlet valve opens and the exhaust valve will be closed. The downward movement of the piston creates the section in the cylinder and as a result, fresh air is drawn into the cylinder through the inlet valve. When the piston reaches the BDC, the section stroke completes and this is represented by the line AB on PV diagram. Compression stroke. At the beginning of the stroke, piston is in BDC and during the stroke, piston moves from BDC to TDC. During this stroke, both inlet and exhaust valves are closed. As the piston moves upward, air in the cylinder is compressed to a high pressure and temperature. The compression process is adiabatic in nature and is shown by the curve BC in PV diagram. As the fuel comes in contact with the hot compressed air, it gets ignited and undergoes the combustion at constant pressure. This process is shown in by the line CD on PV diagram. The compression ratio ranges from 16:1 to 20:1. Power stroke or expansion stroke or working stroke. At the beginning of the stroke, piston is in TDC. During the stroke, piston moves from TDC to BDC. During this stroke, both inlet and exhaust valves remains closed. As combustion of fuel takes place, the burnt gases expands and exert at large force on the piston. Due to this, piston is pushed from TDC to BDC. The power impulse is transmitted down through the piston to the crankshaft through the connection rod. This causes the crankshaft to rotate at high speed. Thus, the working is obtained in the stroke. The expansion of gases is adiabatic in nature and this is shown by the curve DE on PV diagram. When the piston reaches the BDC, the exhaust valve opens. A part of burnt gases escapes through the exhaust valve out of the cylinder due to the self-expansion. The drop in a pressure at constant volume is shown by the line EB on PV diagram. Exhaust stroke. At the beginning of the stroke, piston is in BDC and during this stroke, piston moves from BDC to TDC. During this stroke, the inlet valve is closed and exhaust valve is opened. As the piston moves upwards, it forces the remaining burnt gases out of the cylinder through the exhaust valve. This is shown by the line BA on PV diagram. When the piston reaches the TDC, the exhaust valve closes. This completes the cycle. In the next cycle, the piston which is at the TDC moves to BDC, thereby allowing fresh air to enter into the cylinder and the process continues. Thank you for watching. Please like, share and comment.